This is Unit 2, Segments, Lines, and Angles. Preview video 2.1, Graphing of Lines. Sit tall, ready, and inhale. Deep breath, hold for 3. Exhale, 5. Breath, inhale. Hold for 3. Exhale, 5. Time ready, inhale. Hold for 3. Exhale, 5. Students, you're going to need a straight edge today. Go get that handy. You're going to need a straight edge. This page, do on your own. Pause the video. All right. Hopefully you pause the video and now you have a red pen in hand. I'm not going to explain these. We're just going to write in the answers and then you correct. All right. So here we go. 5 root 2 times root 2 is 10. 6 root 5 times root 5 is 30. 5 root 5 times 5 root 5 is 5. 4 times 5, that's 20. Root 3 times root 3 is 3. 8 times 3, that's 24. What? Root 6 times what is 6? That's another root 6. And 2 root 5 times what is 10? That's another root 5. Today, your vocabulary words are rate, slope, y-intercept, x-intercept, slope-intercept, and point-slope form. Put your arm like so. Tilt. When you tilt your arm, that is a concept of slope. Slope is tilt. Make your arm go like this. Ready? Slope is rise, over run. Use your hands, please. Rise, over run. Slope is rise, which means the up and down motion on a graph, over run, which is the left or right motion on a graph. So the slope of this interesting cushion here would be the rise, would be this distance over this distance, which is run. Rise, over, run. Rise, up and down, run. And slope is always a fraction. Slope is always a fraction, even if you see it as a decimal, which in construction, they often, or you may have seen the concept of grade going down, they may have slope as 0.25. Technically, that's 1/4. Keep that in mind. Slope is always a fraction. You need to be familiar with positive, negative, zero slope and no slope. We read graphs from left to right. So if a graph goes upwards from left to right, it will be a positive slope. Positive slope. If it goes down from left to right, down from left to right, it will be a negative slope. Zero slope, put this right here just to understand zero slope. Rise over run. Put your hand flat. Ready? Now wiggle it up and down and say there's no rise. Okay, stop, put your hand flat again, and again say no rise. So in a completely horizontal position, there's no up or down motion. There's no up or down motion. So it's no rise. So that's a 0 in the rise position. There's going to be a number in the run position, but 0 over anything is just 0. It's important you remember this. 0 slope is a horizontal line. 0 slope is a horizontal line. This last one, trace it. Rise over run. This has rise. There's a number there, but there's 0 in the denominator. So put your hand vertical and wiggle it back and forth. Say no run. It has no back and forth motion. It has no left-right motion. That's why it's vertical. But you cannot have a 0 in the denominator. So this is not 0. It is called no slope, also known as undefined. 0 slope, undefined. 0 slope, undefined. Do not mix those up. What is an X and Y intercept? Physically trace this line, please. Just physically trace it. Darken on the Y axis. The y-intercept is where that will cross the y-axis, and that will always be something that looks like this. There's a number, there's a 0 in the x, and a number in the y. So in this case, your y-intercept is going to be 0, -3. That is your y-intercept. Your x-intercept is where the line crosses the x-axis, which is right here. For x-intercept, you're always going to have a number, 0. So in this case, your x-intercept is 4, 0. Always label your intercepts when you work with them. Now, this seems a little tricky. Ready? X equals -3. X equals 5. So I'm going to write it here. X equals -3. X equals 5. And x equals 8. Remember this moment. What I just did was wrong, because all of these are not points. They are lines. They read like this. All the points where x is -3. All the points where x is 5. All the points where x is 8. So the easiest way to actually graph this properly is to graph a bunch of points that fulfill this. So the line x equals -3, you start. What this point is right here, technically, that is -3, 0. That's not x equals -3. What x equals -3 is you do a bunch of them. -3, 1, -3, 2, -3, 3, -3, 4. All the points where x is -3 is going to be a vertical line. So this entire line is x equals -3. Same thing here, all the points where x is 5. So that's 5, 0, 5, 1, 5, 2, 5, 3, 5, 4. So all the points where look like this. That is x equals 5. Last one, all the points where x is 8. So that's 8, 0, 8, 1, 8, 2, 8, 3, etc. And you do this, all the points where. So all x equal lines are vertical lines. All x equals lines are vertical lines. Keep that in mind. So that means all y equal lines, just add one here, y equals, let's just for giggles say 3. That's all the points where y is 3. So it would go like this, something comma 3. So 0, 3, 1, 3, 2, 3. So this horizontal line going this way, that's going to be y equals 3. Now, graphing using slope-intercept form. This is the form you're probably familiar with. First, you want to make sure you are in this form, y equals mx plus b, also known as y equals something x plus or minus something. So in this equation, you can see we already have it in that form, so we don't need to manipulate it at all. So when you graph, you start with the y-intercept, which is your b. So here our b is 3. Our b is our y-intercept. So you start on the y-axis. You always start graphing using y equals mx plus b on the y-axis. So that's going to be 3. You're going to plot the intercept, and it's going to read 0, 3. I want you to label your b, please. So b is right there. Now, your slope, look very carefully. Remember I said slope was always a fraction? So right here, your slope, you need to turn it into a fraction. It is rise over run. So if you have a whole number, you must pop it over 1. Now, this is where students get confused. They're like, do I go up 3? Do I go down 3? That doesn't matter. What does matter is that the final tilt of your line, if this is a negative slope, which it is, your line must tilt from left to right going downward. From left to right, because it's a negative slope. So to plot this, I'm going to rise 3. 1, 2, 3. I'm going to run 1, but I have to go to the left because it has to tilt downward. So that's rise 3, run 1, and that will give me a downward tilting line. Or I could drop 3 and run 1 this way. But either way, my line must tilt downward from left to right. So that is how we're graphing this line. Please label your lines. This is y equals -3 over 1 x plus 3. Let's do another one. Start by writing your equation. You circle the b, you circle what's right above. You're like, whoop, there's nothing there. If there's nothing there, then technically what's going on is this is plus 0. So that means your intercept there is 0. So we are going to start at 0, 0. And our slope is 5 over 3 is a positive slope, so I know I'm going to go up from left to right. So my rise is 5. And my run is 3. I want my line to tilt upwards, or I could drop 5. and run 3 this way. But either way, my line must tilt upwards from left to right. And this is, I'm going to label it y equals 5/3 x plus 0, technically. Now, what happens when it's not in y equals mx plus b? Y equals mx plus b. That is where you need to get y by itself. All right, we practiced this a couple times. We'll do it again. I'll do this one with you. So step number 1, just kind of circle the y, and the goal is to get y by itself. Okay, y is you. You work far away and then you work close. So I'm going to work far away first. I'm going to take the 10 into the other room. Step 10 equals negative 5y minus 2x. And I'm going to move the 2x. Bring it over here to the right. This 2x and that 10, they do not mix and mingle. This is a couple. This is a single. Couples and singles don't mix and mingle. So this is going to read 2x plus 10 equals negative 5y. Last step. The opposite of multiplying is dividing, and you must divide that 5 by both. So I have negative 2/5 x minus 2 equals y. Most of you don't recognize it like that, so I'm just going to flip it around so you do recognize it. Y equals negative 2/5 x minus 2. Y equals mx plus b. Now we're going to graph. Circle the b. That's my y-intercept. I circle slope, and my slope is going to be negative 2/5. So I know right off the bat, my line must go down from left to right. My rise is 2, so I can go up 2. My run is 5, but I have to go left to make it tilt downward. 1, 2, 3, 4, 5. That's one way. Or I could go down 2 and run 5 to the right. And then I graph my line. Change it to y equals mx plus b. Identify your intercept. Identify your tilt. And this is y equals negative 2/5 x minus 2. I want you to graph this page all by yourself. Pause the video. Graph this one too. And then I'll pick you up on that word problem. Ready? You graph these 3 all by yourself. Pause. Welcome back. Get a red pen in your hand. So y equals negative 6. That's all the points where y is 6. It reads like this. It reads something comma negative 6. So 0, negative 6, 1, negative 6, 2, negative 6, 3, negative 6, 4, negative 6. So y equals negative 6 is this horizontal line right here. So y equals negative 6. Y equals 3 is all the points where there's a blank and a 3. So 0, 3 is right here. 1, 3, 2, 3, 3, 3, 4, 3, etc. It's a horizontal line. Y equals 3, y equals 7. Therefore is also a horizontal line. This is all the points where I have a blank comma 7. And so that's 5, 6, 7. That's 0, 7, 1, 7, 2, 7, 3, 7, 4, 7. And it is a horizontal line. So all of those y equal anything are horizontal lines. For this one, y equals mx plus b. You should have started your intercept at positive 5. So that would be 0, 5 is your intercept. It is a negative tilting line, so your line goes down from left to right. We're going to rise 3, and we're going to, excuse me, I was using red for rise, green for run, so red rise. And you can rise 3, 1, 2, 3, run 2 to the left, 1, 2, or you could have dropped 3, 1, 2, 3, run 2 this way, 1, 2. I purposely made that go off the graph because your brain should not be shrunk to any graph presented. There may be times where your line goes off the graph, and that is okay. Now, why do we need to be able to graph lines? Graphing of lines is what is used for the prediction or tracking trends. It's used in economics and weather, biology, all kinds of chemical reactions, just anything that's reactive in nature you can predict, and part of that prediction can involve lines. But before I introduce that, I need to introduce the concept of independent and dependent variables. Independent and dependent. Let me give you the example of boiling water. Okay. Yeah, boiling water is not the best example. Let's see what's the best. Water, independent, dependent. Okay, time. Let's say a car starts driving, okay, and gains speed, if you will. And there's 2 factors. There's time. You know, they talk about 0 to 3 seconds. Yeah, 0 to 60 in 3 seconds or something like that. And then there's speed. Okay. The speed is dependent upon the time. So your time factor is what is called the independent cause, and your speed would be the dependent cause in this case. And in graphing, the independent or the cause is on the x-axis. That's very important. And the dependent is on the y-axis. All right. So we are going to show you this predictive nature. It says you have a loan of $12,000, a debt. After 3 months, you owe $800 at this rate. How long will it take to pay off the debt? Graph your expression y equals mx plus b. Okay, very careful. We have here, we have a loan of $1,200. That means, and we're in debt by $1,200. So $1,200. We're already in debt. After 3 months, you owe $800. So notice what happened here. We went from $1,200 to $800 in a span of 3 months. So come over here, let's graph that. All right. So here's our month's time. Here's our variables, and the months we're going to put, the funds are in $1,000. All right. So 1,200 funds are in thousands. So this is 1,000 right here. So 1,200 at 0 months, you have 1,200 in debt. All right. And after 3 months, you have 800 in debt, which is right here. And we're going to graph. And the question is, when will you be out of 0 debt?